Today we're going to play with inductor again. I have over here a 3 millihenry inductor out of a old LED light bulb. Got it connected up to my signal generator. The display on this has gone very dim, so even I battle to see that. But on the scope over here I can see the frequency, and I am also measuring the phase offset between current, which is blue, and voltage, which is yellow. So currently we are 22 kilohertz. As you can see, the voltage is about 5 volts, and there we have our current. So now I'm going to turn the frequency all the way down, go into the scope, slowed it all the way down. Now you can see something has happened. The voltage has come down, the current through the inductor has come up, and also the phase relationship between voltage and current is sitting at 170 degrees. So in other words, at 300 hertz the current lag after the voltage is minimal. There you can see it over there. They're almost in phase. So now I'm going to turn the voltage down again, and there you can see the voltage coming up, and you can see the current coming down, and you can see the phase shift starting to take place. So as the frequency increases, so does the reactance of our inductor, which means the impedance goes up. So now we're at about 130 degrees. So the current is lagging quite a bit behind the voltage. And if I change the square wave, there you can see how the voltage comes up, and now the current slowly rises. Same with the triangular wave. You see the voltage come up, and you can see the current rise afterwards. Let's go back to square wave. Slow that down again. Let's select those, turn them down. Turn that up again. Turn current up. So there you can see the current rise, the voltage rises, then the current comes up, and because the current from my signal generator out is limited, the voltage comes down, and there you can see the current through the inductor. Now you can see that they're virtually in phase at 300 hertz. So let's go back to 22 kilohertz. There's our current once again. Now because the current is lower, the voltage is staying higher. There's our sine wave once again. That's a triangular wave. There's our sine wave. So slowing that down, we can see the blue current come up, and yellow the voltage go down as we reduce the frequency. So that's how the inductor behaves. The reactance goes up, so therefore your impedance goes up with the frequency. That's 10 kilohertz. Now if you go to 20, that has doubled, like so. So the point where they were equal was 4.5 kilohertz. So if I go to 9, yeah, the current through the inductor is halved. So if I move it, you can see that it's halved. Of course, to double the frequency, you've doubled the impedance. So that's what's happened there. So this is interesting stuff. This is working with inductors once again, and with the signal generator and the scope, we can have a look at how the inductor behaves as you change the frequency through it. And the voltage knob simply changes the voltage, the amplitude coming out of the frequency generator. This is a Instek, a GFG8020CH. It's an old signal generator, but it still works. Does its stuff. So I think that's it. I'm using the standard CT setup that I normally use with the 1K resistor, and it's useful to be able to see what the current through the inductor is doing with the CT and do interesting measurements. Let's turn that up, bring that down again. We're one frequency. Let's go even faster. So there we can see the current has really come down. We're now at 200 kilohertz. If we go to 2 megahertz, there's not a lot of current flowing anymore. The inductor's reactance has become very high at that point. So this is interesting stuff. And I think that's going to wrap it up. I don't have a lot to talk about here with this. We messed around with frequency and saw how that affects the reactance of the inductor, how much current flows through it for a fixed voltage, and how the frequency affects it. It's probably not going to be the most interesting video for most folks. This is kind of deep diving into inductors and magnetics. So I think we're going to wrap it up here. That's pretty much all I have to talk about with this setup. Thanks for being here, ladies and gentlemen. Take care. Have an awesome day further, and we'll see you for more stuff. Cheers.